What's up everyone, my name is Dr. Chris Hacks, and today we're going to be continuing on with our CryptoPals crypto challenges. Today we're going to be implementing CBC mode. So CBC mode is called cipher block chaining, and CryptoPals actually gives a pretty good description here, so let's read it real quick. It's a block cipher mode that allows us to encrypt irregularly sized messages, despite the fact that a block cipher natively only transforms on individual blocks. Okay. Each ciphertext block is added to the next plaintext block before the call to the next cipher core. The first plaintext block, which has no associated previous ciphertext block, is added to a fake 0 ciphertext block called the initialization vector. And then to implement CBC mode by hand, we take our ECB function from earlier, make it encrypt, and then use our XOR function to combine them. And then this file here is somewhat intelligible when decrypted. Okay, so here's the thing. We already implemented the encryption and decryption for ECB mode, so that puts us ahead a little bit. So let's just go ahead and get into it and implement CBC mode. I'm going to also write the encrypt and decrypt for this as well, just so that we have both of the functions, because we will need both later on. Okie dokie. So, let me minimize this here. Alright, so I already set everything up, got the text file, got challenge 10 all set up. We do need to actually read the file, so let's do that real quick. So we will get an in-file stream. I'm going to call this file, and then our path is just going to be 10.txt. And then, of course, we do need our error handling. So let me actually go grab that from like challenge 4. I've been doing this. It's pretty easy. Whoops. Go back to challenge 10. And then if file.isOpen will return file.10 failed to open. Perfect. Okay, so now we have our file open and ready to go. Next up, let's go actually implement our functions. Okay, so in here, I'm going to do this. Let's do string AES underscore 128, and we're going to call this CBC encrypt. And it's literally going to be exactly the same as the ECB encrypt function. Signature. String reference key. Okay, perfect. And then the decrypt will be the same. Perfect. And then we're also going to need one more helper function. I'm going to go ahead and put it in here just so that it's useful for us, but it's going to be called split blocks. So let me show you what I mean. So we're going to actually use a vector because we need to take our data and split it up into blocks of a fixed size. So it'll be easiest to just use a vector to do this. Like so. Const string, oops, data, or is a string reference, and then const, this is just going to be a size t for our block size. Okay, so what this function will do is it'll take in our data, and then it will split it up into different block sizes, and do different operations on that. Okay, so let's go ahead and actually implement this. We go to aes.cpp. I can minimize these. And then because we already have our ECB functions implemented, that's what we're going to be calling. Those are going to be the most important. I do need to include vectors, so let's include that. So these are these top functions will be the backbone of everything, and then the CBC functions will be built on top of that. So I'm actually going to implement split blocks first. That will probably be the easiest to actually implement. Actually, now that I think about it, we're going to have to include our encoding utils anyways. So I think I'm going to move this real quick. Yeah, because we'll include coding utils because we do need the padding functions for these two. So I'm going to put this elsewhere. I'm going to put this in our encoding utils just to keep all the encoding utils together. So I'm going to put has repeating blocks next to split blocks. Yeah, I think that might be a little bit of a cleaner way to organize stuff. And then let me just steal this from here. We'll still need to, actually, we won't even need to include vector because we're including encoding utils, so we're going to put it over there. Yeah, and we already have vector here, so I think this might be a better spot for it. Yeah, this will be a better spot, just to keep everything a little bit more clean. And we'll probably end up using this function later on anyways, so yeah. And then, okay, since we're going to leave it here, we can make it pretty generic. It's just going to be a vector of strings, and we're going to call it blocks. And then for size t, I equals 0, I is less than data dot size dot length, doesn't matter, I've been switching between the two, and I plus equals block size. I probably should add a check here. Let's just do this. If we're gonna do this. If block, I do need to put parentheses around this, less than or equal to 0. Oh no, it's a size t, it's unsigned. So I'm still gonna put less than or equal to 0, even though it's unsigned. It's still one operation, but I guess it doesn't really. Yeah, if it equals 0, I can't put less than because it makes no sense. Okay, if block size is equal to 0, then we're gonna return null. Oh, do I need to import that? I think it's like just a reference to a static void. Like this. What am I doing wrong? Either way, we can just return blocks, I guess. It'll be an empty vector, so it doesn't matter. The problem is, if the block size is 0, then obviously this for loop's going to run forever, so we don't want that. So we do have to make sure this is being incremented. Yeah, so this function we'll have to be a little careful with, but shouldn't be too big of an issue. Alright, so now we can just push back all of our blocks, and that's pretty easy. We just get our data and we substring it. So we're just going to substring from our index to block size. And because our index will increase by, like, say 16 every single time, it'll be, 16 plus 16. So 0 to 16, and then 16 to 32, etc., etc. And that will give us our blocks. Okay, and then we just return it. And that's all we need to do for this function. So pretty straightforward. Let you guys look at it for a second, then I'll close it here. Okay, now we can go back to our encrypt function. So let me jump over here, close all this stuff real quick, clean it up a bit. Okay, so if we go back to what we wrote down, the way it works is the first plaintext block, which has no associated ciphertext blocks, is added to a fake ciphertext block called the initialization vector. So we're going to make an initialization vector, and what we'll do is we will XOR every single block against the initialization vector, encrypt it, and then use that new encryption. We'll add that to our output, and that encryption will go back and become part of the new initialization block. So I'll show you what I mean here. So let's just I'm actually going to write out the steps for this real quick. So we're going to, first we need to pad our text. So pad plain text. That's going to be using the PK7 stuff we used earlier. Then we're going to actually split our blocks, create the IV, and then we can actually start doing the operations. So we're going to XOR the block with the IV. So I'll call it previous block for now. Oh, I guess I should add an option to pass in an IV, huh? Okay, we'll do that in a second. Yeah, we probably should pass in the IV. And then the block size, we should probably pass that in as well. So let me add both of those actually to the signature. And then size, t, block size. Those are probably things we should pass in rather than let the function come up with. That way we don't always have to have a blank initialization vector. And then here we obviously need a, we can't have a blank initialization vector. Okay, let me update the signature as well over here. Okay, that should fix some problems later down the line. Alright, so then we'll XOR the block in the previous block, and then after doing that, we can encrypt and add encrypt to ciphertext, and then the previous block equals encrypt. And that should do it. That should be our little function. So there's also a for loop here for every block, for each block. Okay, so we'll use a for loop, or for each loop there. So that's sort of our function here. I'm just going to write it out just to make it a little bit easier to understand what we're actually doing. But now we can just go through and implement it. So I'm going to need our padded plaintext. Call it padded data, and we're just going to make that. I'm going to use PKCS7. Pad PKCS7, plain text, and block size. Oh, we're not using plain text, we're using data. It's weird because I'm switching between data and plain text. I should keep it consistent, but I use data here, so we'll use it here as well. What did I call it? I'm pretty sure I called it ciphertext, huh? So we're returning plain text, and we're returning ciphertext. Yeah, so I'll keep that consistent as well. But you guys can name your stuff whatever you want. If it's for you, if you're not working like on a team with something, it's good practice to have descriptive variable names, but you can really just choose whatever you want. Alright, so we'll get our blocks. And block size. Okay, and then we do need our previous block. So what I'm going to do, I'm going to have something called prev block, and it's literally just going to take the IV, because that's going to be the string we're passing in. That initialization vector will be blank, but we will need to hold on to our previous block so we can do operations on it, or with it. Ciphertext. Okay, and that should be everything we need. I can actually reserve our ciphertext. It's just going to be data, or it's going to be padded data. Dot size. The reason why I'm going to reserve that is because this padded data will have the same size as our ciphertext, because we're going to pad it, and then our ciphertext is going to do all the blocks, and then say we have 5 blocks, this is going to be 5 times block size big, basically. Okay. For constant auto reference block, which is just going to be a string. I could write out string, but we'll be lazy because all the for each loops in C++, pretty much every single one I've seen that's like more modern uses auto. We can use auto for so much, but I like having my types there, but we'll use it here just to follow a standard, basically. Alright, so string. So we need to hold on to the XORed output. So the XORed output is just going to be, we're going to XOR. I gotta remember, what did I call this function? Because I know we wrote it earlier. We called it fixed XOR. Fixed XOR and repeating XOR are going to be identical. Actually, I'm going to use fixed because we already know that the two are going to be identical. So I don't need to do any extra checks. So encoding utils.cpp. Because if you remember back to fixed and repeating XOR, these functions are almost identical. Repeating XOR is basically fixed XOR with a slight modification. I'm going to go ahead and use fixed XOR because it is a little bit faster, and we should be having blocks that are exactly the same size as our previous blocks. So it's better to use fixed XOR here. So I'll pass in block and previous block. Okay, so that will give us our XOR. So we're XORing our initialization vector with our block. Then we'll have our encrypt, and that's just going to be AES 128 ECB encrypt. So this is the backbone of everything. We're going to be calling this function quite a bit, and it is quite literally the driver for this entire encryption. We're just doing a couple of slight modifications. Okay, and ciphertext plus equals encrypt, and then previous block is just the encrypted block that we just put. Okay, so we do that for every single block, and then we get our ciphertext. There we go. Perfect. I'm going to delete the pseudocode. Actually, I'm going to copy it real quick. But yeah, that's all there is to it for the encrypt. So the encrypt's pretty simple and easy. Now we just go down here. We're going to basically be doing this in the opposite for our decrypt. So what do I mean by that? Well, we're going to basically do everything opposite. So let me show you. First things first, we're going to split our blocks. And we're going to remove our padding at the very end. Okay? So we need to split our data into blocks anyways, so that we can actually work with it. std vector, standard string, blocks equals split blocks, and we'll take our data and the block size. So we'll get our blocks real quick, and then we can get our plain text. And I'm actually going to call it padded plain text. Because if you remember, we had to pad our data here. We're going to have to undo this. So our function requires the data to be a standardized size, which is hence why we're padding it. However, we will need to unpad it in order to get the original data. So string plain text, and then we're going to have a temporary IV. Because we're using a constant IV, I'm going to create, yeah, we are going to need a temp IV. Or I could just make this one non-constant. I'm going to make this one non-constant because and I'm also going to make it not a reference. That way we can safely utilize this. This is going to copy it into our function. I want to make sure we can use this initialization vector without messing it up for wherever passes it in. So I'm going to change that real quick over here, instead of just blindly following the constant pattern. Okay, so we don't need to do anything. We already have our initialization vector. All right, so for constant auto block in blocks. Let me put the reference on the right side. It's basically for every string of block and blocks. We are going to do this. All right, so first we're going to make a string called decrypt, and it is literally just going to be our AES function decrypt. We're going to block and key. Okay, easy peasy. Now we do have to decrypt it with our initialization vector. So we don't actually know what the original initialization vector necessarily is. so that's why it's going to be somewhat intelligible. You might lose a block or two, but we'll see. So here's how we're going to do this. We're going to actually assume whoever's calling knows what the initialization vector is, but if it is wrong, it can mess up the encryption and decryption. So because we're starting from the beginning, we're expecting a blank one anyway, so it doesn't even matter. So never mind. We're just going to pass a blank one in, and it should work because we're starting from the beginning, and it will propagate through. Okay, so fixed, XOR, decrypt, and our IV, and then plain text, padded plain text plus equals decrypt, whoops, and then our IV is equal to block. And that will undo everything we just did for encryption. And then all we have to do to return is unpad pkcs7, and then we pass in our padded plain text. And the reason why we're doing this is because we put the padding on earlier, so now we got to get rid of it. Now if I go back to encoding, if I go back to challenge 10, that should be it. That should be the entire encryption decryption. So let's go ahead and actually check it. Okay. So we do have to read our files. Let me just be lazy. I'm gonna go grab it from 7. I've been doing this just because it's quicker. Okay, I believe it is already. Is this base 64 encoded? It looks like it is. It doesn't say it explicitly, but I'm pretty sure it is. So let's just do that. So include encoding utils and include AES.h. Okay, so here's our data, and we already know what our key is. Const string key equals yellow submarine. Okay, perfect. Now let's go ahead and decrypt. So I'm going to return CBC decrypt. We'll pass in all of these different things. So we're going to pass in data. We're going to pass in key. We're going to pass in our IV. So let me make our IV real quick. Const string IV is just going to be it's going to be the null character. Or I should probably use the char. Right, let me remember. I always get this mixed up. I always get mixed up which one's the number of characters and which one's the actual character you want to put in. So we'll see. 16. I believe it's. Let's see. It is going to be. It looks like it's the other way around. Yeah, so it's number of characters first and the actual character you want. Okay, perfect. Yeah. Okay. So now we're going to get 16 zeros, so we can pass that IV in. And then we will also pass in the block size, which is just 16. I could declare that as well here, but it's not going to change. Okay, so let's moment of truth this. Let's see if it actually works. It's got to recompile everything, huh? Alright, there were build errors. Let's see, where are the errors? Error list. Challenge 10 not found. What do you mean? Alright. Here's challenge10.cpp. Challenges, I put challenge 9 twice. Copy and paste error, of course. This is ambiguous. What? What? What do you mean? I literally copied and pasted this. Okay, so that's just a non-error. That one doesn't even exist. Alright, let's let this redo everything real quick. Okay. It's running, and it ran out of space. Of course. Of course it did. Alright, let me do a little bit of troubleshooting, and then I will get back to y'all. Alright, everyone, I'm back. So after checking my notes, I realized that we needed this line. So in the encrypt and decrypt functions, basically what are we doing? We are padding all of the data ourselves. That's why we implemented the PK CS7 stuff, because we needed to pad the data. Therefore, we need to turn off the OpenSSL padding. This function does. So we're just going to basically set their padding to 0 because we're already doing all of that on our end. It's a little bit weird. It's a little bit complicated. So without getting into the details too much, we're just going to turn off their padding because we're going to handle it ourselves. So in the decrypt function, I put it right after we initialize the context variable. Same with the encrypt function. Right after we initialize the context variable, turn off padding. And that goes ahead and that actually fixes the problem. That was the only change I needed to make, which is why we have the pad and unpad functions. Okay? So it looks good. All right, and then now what I'll do as well in order to test it, of course, I'll do this. Okay, so we'll decrypt the data. Oops. Then we're going to go ahead and re-encrypt it. And then we will decrypt it again. So we'll just do this. Just to verify that both our encrypt and decrypt functions are working properly. I'm also going to use, instead of data, I'm going to do this. I'm going to put in some like random stuff. So just so that it's like a weird size so we can do all of our padding and everything and then it like works correctly. So let me do this. I'm going to put in a test string. Okay. And that's just a random string. And we're going to also return print as formatable. And the reason why I'm going to do this is because I want to make sure there's no special characters at the end. What I call it, print utils. Yeah. Print as format. Did I spell that wrong? Oh, format as printable. That's what I called it. Okay, I just want to make sure there's no weird special characters at the end after we decrypt, encrypt, and decrypt. Oh, what am I doing? Hold on. I can't. Hold it. I gotta not call this first. Gotta encrypt it before we decrypt it, otherwise it throws an error. Let's stop this and run this again. And it threw an error. What is wrong now? Alright, hold up. Okay, let's slow down here. So here's our generic test string. Here's our key and our initialization vector. We are encrypting and then decrypting. Let's go through and see where the error is throwing up. Take a look at the call stack. Let me do a little bit more debugging. Okay, nothing's wrong with our functions. I'm just being dumb and I'm passing an uninitialized variable into here. That's why it's mad, because you gotta initialize your variables. Oh, what a rookie mistake. Okay, now, hit my breakpoint. Let's skip that. Okay, I don't need the breakpoint. This is a test string, hopefully. Okay, cool, and there's no character. Perfect. That's exactly what we wanted. That's how we know that both of our functions work correctly. Okay, cool. So now, what I can do is this. I'm just going to copy this string, put it in here. I'm going to use format as printable, even though we already know all of our characters are going to be English characters. They're going to be readable. I'm going to put that in there anyways, just so that if there are any weird extra characters at the end, we'll see it. One more time just to make sure it's good to go. Okay, it does look like there are a couple weird characters. However, I know why. Because they're like weird return lines. But it did say it was mostly legible. Okay, cool. I can actually get rid of this format as printable then, because it was looking a little bit better beforehand. But it's using ASCII character A. Let me check what that is. Whoops. Okay, yeah, because look, it looks really good here, and then it was pulling up ASCII character 0xa, which is going to be, if I check over here real quick, the line feed. That makes sense, because line feed is just a new line. Okay, so we don't need to worry too much about that then, and everything works. We got the song playing. So thank you all for watching. I'll upload this to our GitHub, and tune in next time for the next CryptoPals Crypto Challenge. See you all in the next video.